All right, in this example, we're given the graph of a linear and an exponential function, and we want to find the formulas for each function. All right, and we're given 2 points, right? Both of these functions pass through the same 2 points, and we're just going to find the linear function and the exponential function that pass through those 2 points. So let's start with the linear. That's the easy one, right? Linear function, the general form is y equals mx plus b. Right? Now I'm going to do this in a similar way to what I did before, and the reason is just because it's closer to what we're going to do with the exponential function. So I have x and y values. I have x and y values for 2 points. So I know that y is 57 when x is 6. So I'm just going to substitute those values into the general form. So I get 57 is equal to, I could rewrite this as 6m plus b. And I'm going to do the same thing with the other point. I know that y is equal to 13 when x is equal to 2. All right, so now I have 2 equations and the 2 unknowns, m and b, that I need to find in order to get the equation for that line. So what I'm going to do is I'm going to use elimination here because I see I have plus b in both of those. So if I take this second equation and just subtract it from the first, then I'll be able to eliminate b. So 57 minus 13, that's, 44, right? And then 6m minus 2m is 4m. So I can see that m is equal to 11. All right, and then I'll just take that value and put it back into either one of the original equations, and then I can find b. So I'm going to take the second one just because it has smaller values, right? So 13 is equal to, I know m is now 11 times 2 plus b. So 2 times 11 is 22. I'm going to subtract that from both sides, and I get minus 9 is equal to b. So my formula for the linear equation is y is equal to 11x minus 9. All right, that's my linear equation. I'll put a little box around it. That's my answer. All right, let's do this for the exponential equations. So it's kind of hard. I can't see both of the points. You can see, I'm sure you can see it on your page. So all right, let's do the exponential. Let's abbreviate it exp. The general form is y is equal to a b to the t, right? So I'm going to do the same thing I did before. I'm just going to plug in the t, or actually it's x, isn't it? So when I just say, let's call it x. X, a, b to the x. I'm just going to put in the x and y values. So I know that 57 is equal to a, b to the 6th, right? Because when x is 6, y is 57. And I know that y is 13 when x is 2. So I have 2 equations, all right? This one doesn't work out as nicely as the last one where we had the initial value, right? The initial value is not given. We're given the values at 2, x equals 2 and x equals 6. If we had x equals 0, it'd be a lot easier, right? Because then we can directly solve for a. We know the initial value. Here we don't. We don't know what the initial value is, but we have these 2 equations. All right, so how do we solve this? Well, if I divide one by the other, right? Now if I divide each side of this equation, I have 57 equals a, b to the 6th. And if I divide that, these are equal quantities. So if I divide this by 13 and divide this by a, b squared, right? I'm just taking both sides and dividing by equal amounts, which is legal. Right? I know that ab squared is equal to 13, so I'm dividing the 57 by 13, and I'm dividing the ab to the 6th by ab squared. All right, then I can see, all right, the a's are going to cancel. All right, and I can see that I have b to the 6th over b squared, which is b to the 4th, right? This is b to the 4th. So now I can solve for b. So the key here is to divide the functions. We subtracted up above, but here we're going to divide the functions. So I'm just going to get b is equal to 57 over 13 to the 1/4 power. All right, and if I put that into my calculator, I got 1.44705. All right, so that's my b value. I got b now. All right, let me give myself some more space. So now that I have b, I can just put that into either one of the original equations and find a. So I'm going to take the second one, 13 is equal to a, and then it's 1.44705 squared. Right? I'm just plugging that into the second equation, and then I can divide both sides by this 1.44705 squared. So I get 13 over 1.44705 squared. And I can put that into my calculator and find that a is 6.2084. All right, now I have a and b, and I can write the exponential formula for this, for the equation, for that exponential function. So we have y is equal to a, which is 6.2084 times 1.44705 to the x. And now that is my exponential function that passes through those 2 points. All right, there you go. So the key here when you're solving for the parameters a and b for an exponential function is to divide. All right, I will, I guess that's all I have for you for this section. So I will see you in class.